So, good afternoon and welcome to my presentation about the opportunities and challenges of smart textile systems for occupational safety of electricians. I'm Jasmin and I am working as a textile engineer at Adhesive since the beginning of this year. And first, I would like to tell you a little bit more about Adhesive and why we started working on smart textile systems. And then I will go on about the different opportunities and challenges. And in the end, I will show you a practical example of the smart textile system, which is used for the occupational safety of electricians. Adhesive is a small company based in Salzburg with about 21 employees, which develops innovative test and safety solutions for the energy sector. Adhesive belongs to Omicron Electronics, which is based in Klaus and Vorarlberg. And Omicron develops equipment for power system protection and measuring devices. This test equipment, which is used in areas of high voltage and strong current, meets the highest standards regarding occupational safety. But nevertheless, accidents still happen, which can have fatal consequences. Eventually, there was a point where the devices couldn't be made any safer. And that's why the vision formed to create the opportunity to detect current flowing through the body. And this can be done through a smart textile system. And the idea is that you can detect an electrical accident and then turn off the power or call an emergency. Now I would like to give you a few definitions about smart textile systems before I go more into detail. A smart textile system is an assembly of smart components which are integrated in a textile. Those smart components are typically sensors, actuators, electrical conductors, and a data processing unit. Furthermore, it is also defined through its interaction with the environment. Depending on its components, smart textile systems can be categorized differently. There are systems with or without an energy or communication function. And through such systems, the opportunity is created to collect, show, and transmit information about the user and his or her direct environment. And that point brings me directly to the several opportunities of smart textile systems. Not only interesting data, such as vital parameters, can be collected and processed. Another opportunity is that due to the integration of electrical components in clothes, no additional equipment is needed. Furthermore, emergencies can be detected early and thus accidents can be prevented. Also, awareness for specific situations can be created through anonymous statistical data. For example, the number of unreported voltage accidents is estimated to be very high. And through systems which detect those accidents, this number could be clearer. Adhesive saw the chance especially in the detection of electrical accidents, faults, and motionless, and then to automatically activate the individual rescue chain or call the emergency contact. 2017, Adhesive began the project to develop a smart textile system which can develop voltage accidents. And in the beginning, the company thought that the biggest challenge would be the development of the software, the hardware, and also the algorithms. But they quickly realized that the smart textile area has many challenges to face too. And I would like to describe now some of the challenges that Adhesive has faced. First of all, few manufacturers. There are some manufacturers of smart components, such as textile conductors and conductive yarns and electrodes, but there are only few which assemble them to a smart textile system. Prototypes and manual manufacturing. Many of the existing systems are rather prototypes and are produced by many manual manufacturing steps. Mass production and costs. The smart textile systems which were and still are on the market seem not to be mass produced, and that's why the price of such systems is so high. The integration processes and component diversity. There are only a few automated processes for the integration of smart components. In the electrical industry, those processes are established for years. In contrast, in the smart textile industry, we have a huge component diversity. Also, we don't have so many manufacturers. Every component has its own integration process. For example, there are conductors which are already integrated in a fabric. Some has to be sewed or embroidered, or some must be thermic bonded. The component compatibility. Not all components are compatible depending on the application method. That means if I use conductor A, I cannot automatically connect sensor X and Y with that. The use of non-textile processes to integrate electrical components in textiles is a challenge as well. Processes like stripping, soldering, and crimping are new for the textile industry and mostly not applicable. Furthermore, the tolerances between both industries, that means the electrical and the textile industry, distinguish a lot. In the electrical industry, measures must be accurate to 0.01 millimeters, and in the textile industry, it is more like 1 centimeter. Another aspect is that connections between electrical components are more fragile in textiles. The influence of different washing parameters, such as mechanics, temperature, and chemistry, can be an extreme load during the washing cycle. But Adhesive decided to face those challenges and then developed different processes which are suitable for mass production. One example is our way to establish contact points. And for that, we use a method called non-conductive adhesive bonding. During this process, heat and pressure is applied on the electrical contact area, and so the insulator is squeezed away. And as a consequence, the conductive materials touch. And there are two machines which can be used for this process. One machine is a thermal hot cold stamp press, which we developed at Adhesive, which you can see on the left picture. And another machine is the ultrasonic welding machine, which you can see on the other picture. Another process which is suitable for mass production in smart textiles is hot air taping. And this process can be used to apply a conductor in a fast and reliable way. The topic of washing stability is also huge for smart textiles. And to test the washing stability of our components, we often conduct washing tests. And here's one example where we tested several samples which contain 4 NCA bonded contact points. On the picture, you can see one sample, and all samples contain 2 conductors which are connected to buttons via silver fabric areas. And before washing, all contact areas are covered with a conductive patch, with a waterproof patch. And in the diagram now, you can see the results of the test. And you can see that the electrical resistance up to 60 washing cycles is quite constant and lower than 30 ohm. And an analysis showed that the increased resistance after 60 washing cycles doesn't originate from the contact points, but from the silver-coated fabric. Now, coming to the end of my presentation, I would like to show you a practical example for smart textile system for occupational safety of electricians. It is called Angel and was developed by Adhesive. It is made out of cotton, which makes it comfortable to wear. In both cups, electrodes are integrated, which have skin contact. And those electrodes are connected to a central control unit, which is called Genius, through a textile cable. And when a worker comes in contact with current, with a hand or harmed, the system can detect the current which is flowing through the body. And this is done by a voltage drop between both upper arms. The data processing unit is connected by an app with the smartphone. And over the smartphone, the rescue chain can be activated. And I want to stress that through this system, a voltage accident cannot be prevented, but it's working more like an airbag. So when an accident happens, the consequences can be hugely reduced. And last year, the system was launched and is now produced in a standard sewing factory in Poland. It is washable in a domestic household machine for about 50 washing cycles. And at Adhesive, we are sure that there will be more challenges to face, but we all see the big potential of smart textiles and are excited to see how the smart textile market will develop in the future. Thank you for your attention, and if you have further questions, feel free to ask them, or you can also contact me later.